computer. Okay, so last time we talked about disjoint, a little bit recall, right? And then the additional rule, and then the multiplication rule only used for what independent, right? If A and B are independent. And then the conditional rule. Now, showing two events are independent, you're going to be asked to show A and B are independent in circumstances. You have two methods. Either you show me P of A and B equal to the product of probability A and probability B, or you can use the conditional probability for independent events. Okay. So pick one. Sometimes you don't get to pick. Sometimes you don't get to pick because depend on what you have. If you have, you can calculate P of A and calculate P of B and calculate the P of A and B. Then you go ahead and use the red one. But what if you don't have P of A, right? Or say you don't have P of B, but you have P of A given B and P of A, then you can use the second one. Okay, so move on. For this problem, it's gonna be, this problem is something similar to your exam. It has everything. Les Miserables by Victor Hugo is considered a classic novel. A movie based on the novel was released in 2012. The probability that a randomly selected adult has read the book is 15%. The probability that a randomly selected adult has watched the movie is 45%. And the probability that a randomly selected adult has read the novel and watched the movie is 10%. If I was you, I'm going to make a little summary. So P of red is 0.15. Maybe I'll make this blue. P of watch is 0.45. And then P of both, yellow, read and watch is 10%, 0.10. If I ask you to draw a Venn diagram, in this problem it doesn't, but say if I ask you to start with the box, right? Again, the box consists of what? What the box represent? Yeah, all of your possible outcomes, which is sample space. Now, event is a subset of sample space. Right? Event is one of the subset of the sample space. In your sample space, there's two or more events. Okay, so now the blue circle is going to be probability of red, and then the red circle is probability of watch. Because how do I know that it's not it's not destroyed? How do I know it's not destroyed? Yeah, the intersection, right? It's not equal to 0, so apparently it has to intersect. So the yellow right here, that's P of A and B. So this one is A, this is B, and this is A and B. That's how I want to represent on your exam. If I ask you to draw a Venn diagram for the problem. All right. What is the probability that a randomly selected adult has not read the book? So in terms of math notation, I want to know P of has not read the book is mean read complement, right? The opposite of read is not reading, which is read complement. Which is has not read the book, so that B, don't draw this down. Everything except for the blue circle, right? You don't have to shade this. Just gonna show you visually. So everything in the green part, except for the blue part, is a sample space, right? Which is sample space minus the blue circle, right? Sample space is 1. Everything is 1 minus P of read. Remember the complement rule? Complementary rule So 1 minus probability is 0.15, so 0.85. Roughly 85% of people don't read the novel. What is the probability that a randomly selected adult has read the book or watched the movie? So this is P of read or watch. Or mean what? What rule I'm using here? You don't have to tell me the name. What will you write next? What would I write next? Yeah, so P of read plus P of watch. A is read, B is watch, right? Minus P of both. Read and watch. On the exam, I do want you to write things out like that. If you give me the answer, I'll probably give you a point. You gotta know what your presentation is important. Read is 0.15, watch is 0.45, both is 0.10, 60 minus 1050, 0.5. Yeah. Oh, sorry. Oh, I'm so sorry. I forgot. My bad. Sorry, guys. I recorded, so if you missed the first part, you can always come back to the video. Sorry about that. All right, what is the probability that a randomly selected adult has read the book given this person has watched the movie? Why don't you guys do this and put in the chat privately? Number 3. When you see given, that means you use conditional probability, right? You need more time? Please. All right. Maybe people need more time. Feel one half a minute. I really don't have a lot of time today. Okay, all right. Let's see. Tyler 0.9, Rami 0.3, Fatima 0.9. All right, so thank you for your response. Rosa 0.9. Okay, I don't know it yet. Let me see. So P of read, read, given watched. P of A given B, right? So P of read and watch divided by P of watch. I don't want you to think of it as a division, but it's easy to remember. Whatever behind the vertical line, that's the denominator. Maybe that's easy for you to remember. All right, P of read and watch is 0.10. P of watch is 0.45. What do you have? Okay, yeah. 0.45. 0.222, right? Yeah. Yeah.
So when you see that, I understand how we use that.
Mm-hmm.
Do we have to, how do we know it's always like read and watch? Other read and satisfied in that time. So like, how do we know like
Which you use?
Yeah. Which
Oh.
from that list?
Okay, so for number one, you know it's complement, right?
Yeah.
For number two, you know is additional.
Mhm.
For number three, given. You see two clauses here. Be given watch. Yeah, two clauses. Yeah, whatever you see given, then you know that is conditional.
Oh, so it's saying like those people have read the book, but they've also watched it.
Yeah, yeah, given. It's called prior probability in Bayesian analysis, but I'm not even go to Bayesian because at this level, you don't have to. If you want to go for statistic, they dedicate a whole course for Bayesian analysis, which is this conditional probability. Now on your homework, they don't always say given. It's a little bit more ambiguous, but you just gotta read it carefully. Okay, whenever you see two events, then it likely is conditional. Something happened first and then something. All right, number 4. We're not gonna do the chat. I'm just gonna go ahead and do this. So P of same thing, right? Is conditional probability, but now it's reversed. Probability if someone watched the movie, given they had read the book. Watch, given has read the book. So P of watch and read the same as read and watch. Right? They're not changed. Divided by P of read is the P of watch and read. The both is 0.10. P of read is 0.15. 0.67. If I don't tell you how many decimal place, go ahead and whatever you want, okay? As long as the number is close to the values. All right. Number 5, our event randomly selected adult has watched the movie and a randomly selected adult has read the book independent. There are 2 ways to do this here. In this case, you can pick. You have everything. You have P of A, P of B, P of A and B, and you also have P of A given B. You have everything. You can pick. I'm going to do both. Let's just demonstrate it to you. The first rule, use red. P of A and B is indeed equal to P of A times P of B. So equal. So what is P of A and B equal? 0.10, right? P of A and B is 0.10, P of both. You know what? Let me write it in terms of the context. So here imply P of read and watch. It is equal to P of read times P of watch. I don't know yet, right? So P of read and watch is 0.10. P of read is 0.15. P of watch is 0.45. Is 0.45 multiply to 0.15 give you 0.10? I don't think so. Right. So nope. methods 2. So this is method 1. Method 2. Are you blue? I'm going to use this rule. I'm going to use P of A given B is equal to P of A. This also implies that A and B are independent. P of A and B. So say P of given watch. Some people like me, can I do watch given read? Yes, you can. So if you start at P of read given watch, then on the right hand side it should be what? P of read, right? If you start with P of watch given read, then on the right hand side is P of watch. Okay, so depends. P of read given watch, that's number 3.222 something, right? 2.22 versus is it 0.1? 0.15. Right. So absolutely not equal, right? Not equal again. So both methods prove that if they're not independent. Pick one. You don't have to show me both. Sometimes you'll be able to pick, sometimes you can't. Use what you have. Do you have any question for this one? You likely to see something like this on the exam. Maybe I modify it just tiny little bit, slightly little bit, because I'm going to put on the practice exam. I even started which one is going to be on the exam, but you can understand. Okay, if you don't understand, you still get it wrong. All right, so now it's tree diagrams. This is a very back in the day when they don't have computer. Now you can plug in the computer, it will make a tree for you. It's called tree. The forest. I think the forest method. I know there's random walk. I forgot. All of a sudden, I forgot. I did it just like 2 years ago. It's a tree. It's a forest. Yeah, forest analysis. So it's like branches out. But we're gonna do by hand because we taking baby steps here, right? Who dates online? The number of American adults who have used online dating or mobile dating apps continue to grow, with the largest increase occurring for young adults aged from 18 to 24. Well, I thought you guys young, you could just go out and find people easy. But internet era. Looking only at adults under 65 years old, about 17% are 18 and 24. If I was you, I'm going to summarize the data. On the exam, you will see this. That's yours, right? I'm just going to do right here so you see. So probability of someone from 18 to 24 years old, 17%. Probability for someone from 25 to 44 years old, 41%. And from 45 to 64, because we only do under 65, is 42%. So far, so good? Just summarize. A Pew Research report that 20% of those aged 18 and 24 have used online dating sites. This sentence right here, that's conditional probability. You just don't see it. That's conditional probability. So you tell me, if hypothetically, if you don't see this, would you be able to tell me which one is the probability that you're looking for? Which one is the given probability? Will you be able to tell? Will you be able to tell? The one that you're supposed to find and the one that is given to you? If you read it carefully, I know that given someone is from 18 to 24 years old, they use online dating sites, right? So given is the age group here, and the probability that you're looking for is an online dating site. So P of online dating site given age 18 to 24 is 27. Same thing here, same thing with the second, the next sentence here. 22% of those from 25 to 44 and 13% of those age 45 to 64. So these just summarize. What percent of American adult under 65 have used an online dating site? Wow. So they're asking for, yeah, they're asking for everything. They're asking for all the group age. I don't want to do by hand. It's required multi-stages. So what I'm gonna do, I'm gonna set up a tree diagram, Venn diagram. Now we have tree diagram. Okay, so if I was you, my first branch, my very original one, it's gonna be adult under 65 years old, right? Yeah, adult under 65 years old. Don't worry about the number yet. I want you to be able to do the branch first. So how many group age under 65? 3, right? 18, 24, 25, 44, and 45 to 64. Don't worry about the number, not just yet. Be able to branch the stuff out. Just kind of like when you did complete randomized, remember those? Kind of like that. So under 65, branch out the 3 groups. And within each group, either they date or they don't. Either they use online dating or they don't use online dating, right? So those are branches. And now you plug in the number. And now you plug in the number. How do I plug in the number? Well, right here, that's why we summarize the data, right? So someone from 18 to 24, that's 17%. Right there, right? Someone from 25 to 44, 41%. Someone from 45 to 64, 42%. And someone from 18 to 24 use the dating site, online dating site is 27. Well, what the other one that doesn't use it, complement rule, right? 1 minus 0.27 is 0.73. That number you have to come up with yourself. The number you come up with yourself, maybe I'll highlight in red. So this one, the one you come up with yourself is the highlight in red. My bad, I'm gonna switch because red for dating, yeah, right there. Make it consistent. Yellow. Okay. And same thing with the next range, 25 to 44, 22% use online dating sites. So the other portion that does not use the online dating site is 0.78, right? In the yellow one, you come up with yourself, take 1 minus 0.22. And the last one, same thing. Do you have any questions so far? You will have one like this on the exam. Rami? Rami or Randy?
Rami.
Rami, okay.
So the dating, yeah, so you just have to be able to summarize all the data beforehand. You would have to provide it. So
No, I don't provide this. You don't have to. Some people are just very agile. They remember it. They come back and they go to draw it. They don't have to, but it's for me, it's if you methodical, it's easier for you. You're less likely to eyeball the wrong sentence. Do you have any question here? It's kind of like complete randomized, right? I was worried about the number last. That was you. I will worry about the branch first. My category. Category come first, number come later. Okay, probability. Somebody, all right, how do I come up with those numbers on the right? Well, somebody use the online dating, given the 18 and 24 in the adult group under 65. All you have is you take 0.17. So this number right here, you take 0.17 times what? Yeah. Oh, how come it's oh. Don't tell me it's gone. Hang on. Let's see. Yeah. Let me go back there. You do it yourself. Sorry, my pens I use so much. Yeah, you take 0.17 times 0.27, you get 0.40495. And same thing with the second one, right? You take 0.17 times 0.73, small one. Do you have any question? Right, and on and on. I'm not gonna do it. On and on. Okay, let's do this one. I'll give you a few seconds, and I'm gonna charge my pen too. I'll walk around, see how you guys do. You need help, let me know. People, my Zoomer, go ahead and do the white cast and deafness using tree diagram. Remember, I need to say something about the exam and the day after the exam, maybe during the break. If school cancel, let me know. Okay? OCC did, I think. I don't want to cancel. I'm teaching right now. You're smoking the wrong stuff while you're canceled right now. I'm teaching, but the all event person classes and activity are canceled. That's OCC. That's not us. Did I give you everything? Let me see. 95% choose random. 40% online. Okay. No, I'll give you everything. Yeah. You walk around, see how you guys know. Oh, okay. Mhm. Mhm. So first, white cat. I will get a white cat, and then how many? So here, so this one, I do those are the conditions. So you want to look at. So among white cats. No. So in addition, among white cat, approximately 2 blue eye. So within the white cat group, there are 3 subgroups, right? 2 blue eye, 1 blue eye, and other eye color. And then from there, for each of the subgroup is either deaf or not deaf, right? Yes. Does that make sense?
Yeah.
Very good. Very good. It's okay. If you don't get it. So the important thing is you be able to draw it out, and I'll show you how to answer the question. So 95% is hopefully good, very good. The percentage could be good. Yeah, most of you now you get it. So I have a white cat group. A white cat group. Right. How many percent total? 95, right? 95%. Oh, hang on, let me see. Around 95% of general cat population are non-white. Oh, this is non-white, not pure white. Okay, non-white. However, among give me a second. However, among the white cat, approximately 75% with and only 17. In addition, a lot more white cat, approximately 22% have blue eye, 4% have 1 blue eye. So that means only 5% is white cat. Oh, that's so they. Yeah. However, among white cat, approximately 75%. Something wrong. Hmm? Yeah. But I'm thinking these but not, I was at first I was thinking 95% was white cat. But at this sentence here is non-white cat, so only 5% is white cat. Because all we talk about here is white cat, right? Okay, something wrong with this is from the textbook. I'm just gonna fix it. So maybe it's not true, but I'm just gonna fix it for the sake of the problem. White cat. Okay. The problem. All right, so 95 white cat, 95% white cat. Within the white cat group, I have 3 subgroups. What are they? Approximately blue eye, 2 blue eye. 2 blue eye. 1 blue eye, and then other eye color. Maybe I'll talk to the department chair. One and then. Oh, then here only 5% here. That means here only 5%. We cannot do 5% because the rest is more than 5%, right? Does that make sense? I cannot have 5% at the beginning, and then right here I got like what 23% right here. Is it 23%? Right? Doesn't make sense. Okay. Other eyes. Okay. So within each of the subgroup, there's either deaf or not deaf. Deaf, not deaf. Yes. Yeah. I'm not gonna put anything there. So deaf, not deaf, deaf. Not dead. Okay, now the number. Let's see, white cat with 2 blue eye, 23% blue eye, so 0.23 here. And then 4% is 1 blue eye, so 0.04. And then a remainder, so 95 minus 23 minus 4. 25, 90 minus 25, 6. Can't do. 68.
I think it's 73.
Oh, 70. Oh, yeah. Oh, okay. I added wrong. 0.95. My bad. Minus. I got 0.68.
It's out of 100%. It's just referring to white cat.
Oh, I see. Oh, okay, so the problem is not wrong then. Yeah, so point.
It's just weird how they.
Oh, okay. I was thinking 95. Yeah. Thank you. Okay. All right. So the 95% kind of draw you off the road a little bit. Yeah, not necessary. No, I'll make some. I'm gonna read my problem carefully and make sure not giving you actual information. No extra information. All right. Okay, so what happened to 2 blue eye? 77.5, 75%, so 0.75.
It's 0.7.
Yeah, it's not 0.78.
0.73, right? Thank you. Yeah, 7, so 0.73. Thank you. And then so it's not deaf. Is that deaf? Deaf. Yeah, not deaf will be 0.25. That's why we summarize our data. But I don't have space, so I'm not gonna do it. 1 blue eye, 19%. No, 4%. No, my bad. 19%. Double check. 40%. Oh, these are where you eyeball the wrong ones. What I meant. So 0.6, and then 0.19 here, and then 0.81. Yeah. All right, probability. I'll use blue. Probability. You multiply them together. If you have the number, let me know. What you get? Second? 0.05. Go ahead. The first one? What do you mean? Oh, no, not being ordered. As long as your number is correct. Yeah, just tell me the correct number. Is 0.05 correct?
Yeah, I think.
Okay. What about now 1 blue eye? Now 1 blue eye.
0.017.
And then not deaf, 1 blue eye. 2, 4. Okay, thank you. And then other eyes color? And then finite 1. Okay, thank you. Thank you very much. All right, what the question? What they asking? They asking for probability of death, right? Deafness. What is the probability of randomly chosen cat is deaf? So they want P of deaf. Maybe now color, I'll use purple. A randomly chosen cat is deaf. It's deaf. I'm sorry, it's deaf. All right, so that means you want to pick the deaf branch. That branch, you add it together. That's it. All right, so P, so be what? 0.017 plus 0.016 plus 0.137. What you guys got? Can be 4, can be 0.4, 0.3 something. Because 1 and 0, 0, huh? 0.3 something. Oh, is it? Something wrong with this one. This one is, did I wrote it wrong? Yeah, right. Well, 0.17, right? Yeah, no 0. Okay, so 0.17. There's no 0. All right. It's just a mistake, arithmetic mistake. All right, so 0.3 something. 0.323. Thank you. Sound like it. Sound more like it. Makes sense to me. Roughly 32% of randomly. The chance, 30% chance that you're gonna choose a randomly cat deafness is. Okay. So not too bad. Not too bad. On the exam, I will not give you extra information that you don't use. Okay. I don't know why they do this. I don't like extra information that I don't use, especially in math. We don't use extra information if we don't need to. Okay, yay, we're done with chapter 13. I'm gonna stop recording so that I'm gonna start another one.